So in today's video, I decided that we were going to talk about naming compounds. Now, I just had my final for chemistry, and I thought that maybe it would be a good idea to maybe reflect something I can look at my own video and interview you guys who are taking chemistry right now. So I just want to, maybe look at some examples and some of the different things that you can look at. Okay, so these things, some of them are pretty easy, some of them are pretty hard, and some of them you just really have to memorize, like random stuff that, because they're obviously, if you've already known throughout chemistry has a lot of exceptions, and so this isn't one, to make sense. I don't know. Okay, so there are different ones. Obviously, there's covalent bond, ionic bond, these kind of things. So let's start with that. So here we go. We have start with here. So the covalent ones. So here's an example I want to show you. So for example, we know what, obviously you know CO2. Now, how would you know it? Because you would look at the first one. The first one is always, you always say whatever it is, so it's carbon. And you see two of that. So we know it's two oxygen. So therefore what we would do is that we would take, since it's two of them, we'll add a prefix, dioxide. So note when you do these, the ones in the back always have "ide" at the end of them, and the ones that have with the different number is always in the front. So for example, we always have, it starts with the one is mono, then di, then tri, then I think it's tetra, then penta, and etc. Kind of, you can see 1, 2, 3, 4, 5. And most of the different cases. So yeah. So, and here's another one that you kind of have to look out for. So CO, it's not going to be carbon oxide, but actually carbon monoxide. Because like I was saying earlier, that means one, or I can't really see that, can you? So basically that means one. That mono means one, and you only put that prefix for these other two, for the last one. Okay, whenever you have these kind of things. So that's one to look at. And here are the other ones that are a little bit tricky too. So this one is nitrogen. Nitrogen. Oh, wait, I wasn't supposed to say that, right? NO2. And we know it's nitrogen dioxide. Obviously, based on the last one that we were doing. But what if we were going to change it and we were going to make it, let's say, N2O5, just for example. This would be dinitrogen. And note, you would not change you would not put an "ide" at the end of it, you would only put the beginning. And nitrogen, I believe, pentoxide. And so one thing you have to really look at is any of the vowels. If it's penta, but it's with oxygen, you're going to take out the A, so it's going to be just pent instead of penta. Because you can't say pentaoxide, it's going to be pentoxide. Okay, just some things to look at. Oh, and have to actually look at this one because the charges also matter. For example, NO2 minus is actually not nitrogen dioxide, but something that we call nitrite. Now, this is where it gets a little bit more trickier, because there's such thing as NO3 minus, and this is going to be nitrate. And so the thing to realize is that there's only NO2 minus or NO3 minus, with the minus ones that are actually possible. So the smaller one is going to be ite, the bigger one is going to be 8. And just for another reference, if you add H in the front of either of them, this turns from nitrite to nitrous acid. So when you add hydrogen to most of them, it turns to an us acid if it's an ite, or if it's an 8, kind of thinking the difference between ite and 8 is 8 ate too much. 8, like you eat too much. 3, 2 has a little bit more. So, or nitric. So 8 goes with ick, ite goes with us acid. So yeah, if there's anything I did wrong, it probably would be that I forgot the us and not ick, those kind of differences. And those are just some things to look at. But this does not always work with all of them. For example, SO3 minus, and as you can guess, it's sulfite. And SO4 minus, sulfate. And no, it's not always 2, 3. This one's 3, 4, for example. When you add the hydrogen in front, this is not called sulfurous, I believe sulfurous acid. I don't think that's what it's called. I believe just by searching it up on the web that it was called bisulfite ion. So bisulfite ion. And for some reason, they put bi in front, kind of like bicycle. You'd think it'd be 2, but it's actually not. It's a little bit confusing. This actually is not, it's not the only one that goes with this, and this one is also bisulfate ion. So these aren't really the only ones that do this, but these are like some of the different exceptions. So those are just some other things to consider. And I think with that, I can go with the weird covalent ones. The ones that you actually have to really remember, like specifically this one, which is, I don't exactly like, but it's something to look at. So this one, NH3, which you can call nitrogen trihydride. Obviously, the ide for hydrogen, tri, because it's 3. But a lot of people would like you to consider this as ammonia, because this is actually, NH3 is very common with other things. So it's going to be like ammonia something, or something ammonia. Usually it's ammonia at the beginning. Yeah, and for example, NH4, something that I had to constantly remember. I believe there's a minus in the top. I'm not quite sure. Pretty sure there's a minus. It's called ammonium. And so these are kind of the differences to look at. Another big thing, ammonium, a little bit more than ammonia. That was on my test. So yeah, a lot of things to really consider about. And with that, we can go to the ionic. And this one is a little bit trickier, but, or not exactly as tricky, but it's about the same. So for example, CaO, and if you know Ca, this doesn't come up as often. This one's calcium oxygen. So this one is just calcium oxide. Excuse me. But one thing to consider is transition metals. So transition metals are a little bit different. So for example, here you have to pay attention to the electrons. So Al2 SO4 3. Now, like I said, kind of like ammonium and different covalent bonded compounds are going to be in different ionic, or most likely will be. So this one you have to pay attention to the number. So for example, this one's going to start out as, you have to kind of how do I say this, reverse engineer it. So for example, you're going to see, okay, how did it become like this? So what you have to do is you have to put whatever's down here number, go up to that guy. Whatever number's here, you go up there. That doesn't really look very good, but in the end, you're going to see that's going to look like this. And we really don't care about whatever's up here on the covalent bonded one, but for the metal, we do care about the most, because that 3 is what we normally have to pay attention to. So normally this would be aluminum sulfate, but this one is just called aluminum 3 sulfate, but this one's just called aluminum sulfate. Why is this? Because here, I printed out a little bit of the periodic table. One thing to always consider is these 4, from carbon to aluminum to zinc to silver. These 4, or I'm not sure why I have to include carbon, but that's what I've been told. Aluminum, zinc, and silver, you don't have to put the number for them. That's just one thing you should really pay attention to. You don't have to put it. So for example, there won't be silver 2, I believe. There won't be like zinc 3, zinc 1, not aluminum 3 or 2. So yeah. And in that case, you're probably wondering, okay, can you give me an example that has anything to do with any of the ones that I actually have to pay attention to the numbers. So here, and this one I believe will be our last one, just to kind of look at. So let's do, oh man, okay, this one. PPNO2, 4. Now, if you remember from the beginning, this one's going to be nitrogen dioxide. Something to pay attention to. And like I said before, what we're going to do is we're going to put the thing down here. That's 1. Put it up here, and take the 4 here, and move it there. Can't really see it, sorry. The 1 there, put it up there. 4, put it up here. So at the end, you're going to get PB4 NO2, 1. Now, this 4 is really going to matter because that number is very important to this specific compound. And the one up here does not really matter that much. So this one, you're going to get lead 4. And normally you write it in Roman numerals, kind of make it look cool. Nitrate. Trite. So yeah, basically, that's basically how you do it. You take the 4, you put it back there. So it's really something that you'll start to notice is that once you get practice with these, you won't have to write it down all like this. You'll kind of see just by looking, okay, that goes there, do it really quick, and you'll see that that's what you gotta do. So yeah, that's basically it. I hope you enjoyed this video, and I hope this was very helpful to you. I'll see you next time.